We're going to now work through example 5 in the notes, and example 5 is the last conversion problem that you'll work through. So example 5 is a little bit trickier. You really have to read and kind of think through what you're doing. So example 5 says a sample of N2O4 contains 3.49 times 10 to the 4th atoms of nitrogen. How many moles of N2O4 are in this sample? So again, like before, I underlined my given, I circled what I'm trying to find. I'm given 3.49 times 10 to the 24th atoms of nitrogen. I'm being asked how many moles of N2O4 there are. So I'm going back and forth between two different things, starting with atoms of N, trying to get to moles of N2O4. So what I'm going to do is I'm going to take my given piece of information and I'm going to set up a dimensional analysis problem. Now, there are two different ways you could go about solving this, and you're going to get the same answer both ways. It just kind of depends on your thought process. So the top problem, I start with 3.49 times 10 to the 24th atoms of N, right? That's my given. Notice both start out with that. You always start with your given. Now, when I worked through it, I said, well, I know that Avogadro's number, 6.022 times 10 to the 23rd atoms of N, would give me 1 mole of N. Okay, so I went initially from atoms of nitrogen to moles of nitrogen. Okay, so that's what I did here. My atoms of N cancel. Now I'm at moles of N. Now I know that I need to get to moles of N2O4. So what I did next is I used the chemical formula. And I said, well, if I have 2 moles of N, or if I have 1 mole of N2O4, I have 2 moles of nitrogen. That kind of makes a little bit more sense, right? If I have 1 mole of N2O4, and remember I'm trying to get to moles of N2O4, so that's what's on the top here. Okay. In 1 mole of N2O4, I have 2 moles of N. So I went from atoms to moles of nitrogen, from moles of nitrogen to moles of N2O4. Multiply across the top, divide by what's on the bottom. Okay, so what I did in my calculator is I put in 3.49 E24 divided by 6.022 E23, okay, and that's in parentheses, times 2. Okay, so what's on the bottom is in parentheses. Make sure that you do that, otherwise your calculator will follow order of operations and won't give you the right number. Okay, or, in the second way that you could do it, you start with your given, and then instead of going to moles right away, you could say, well, if I have 1 molecule of N2O4, I have 2 atoms of N. So I go from atoms of N to molecules of N2O4. Okay, then I'm going to use Avogadro's number with molecules and go to moles. So what I did here is I said I have atoms. Well, I have 2 atoms of nitrogen and 1 molecule of N2O4. I have Avogadro's number of molecules in 1 mole of N2O4. Notice the numbers that you're multiplying are the same as the first way to do this. So notice there's 2 different ways you could go about solving this problem. Now this is really important because what you're going to find as you're working through AP free response questions is there are multiple ways that you could solve a problem and get the same answer as the person sitting next to you, and both are correct. There's just different routes that you can take. You will find that quite often. Okay, there are multiple ways to get to the right answer. So both of these ways get you 2.8977. Okay, 2.8977. Now, you're given 3 significant figures. So I need to get 2.8977 to 3 significant figures. Okay, start from the left, count over. Okay, 1, 2, 3 sig figs. So this 9 I'm going to have to round. Well, the number next to it is higher than 5, so this 9 is going to have to round up. So instead of 2.8977, when you round, you're going to round to 2.90. So we have 2.90 moles of N2O4. Okay, so we went from atoms, and then our answer has a unit and a substance, right? 2.90 moles of N2O4.